Good morning, everybody. So we're going to talk about the mole and mass. So in the previous video, we talked about the mole and particles. We're talking about mole and mass in this one. We're going to also talk about how to go from moles, mass to particles and back, because you can convert directly from particles to mass if you know the right conversion factors. And then we're going to talk about what the mole and moles of compounds, how that changes. Okay. So let's go ahead and get started, because this one might be a little long if we don't. I'm going to save that for later. I did check. Let's see. Okay. So again, I'm going to try to be a little pop out, because I know you guys like to be able to see me while I'm talking. So yeah. Okay. So if you look at your guided notes, right, the mass of 1 mole varies from substance to substance. So 1 mole of carbon is equal to 12.011 grams of carbon. Okay, but 1 mole of table salt, NaCl, we said in the last video, was 58.44 grams of table salt. Okay, both of these things are 1 mole. Both things have 6.022 times 10 to the 23rd power particles. Okay. But they have different masses. Okay, and so for carbon, we can use the periodic table. And for compounds, you find the individual elements' molar mass, and then you add them together. So we're going to look at that. So to find the molar mass using the periodic table, you're just going to find the atomic mass of the element on the periodic table. Okay. So the atomic mass of an element will always equal your molar mass. And the molar mass unit is going to be grams per mole. Okay. Molar mass unit. So for example, if we wanted to find the molar mass of carbon, we'd pull up our periodic table, look up carbon. Carbon says it has a molar mass of that 12.011 grams. Okay. So if we're writing it in terms of molar mass, we always put in the grams per mole. Okay. Now if we're saying what's the mass of 1 mole of something, it's just in grams. But if we're saying what's the molar mass of something, because we're technically looking up a conversion factor, we need to have the grams per mole on there. So the same thing for molar mass of oxygen. We're going to go look at it. We're going to remember that it is number 8 on the periodic table, right? And it says it has a molar mass of 15.999 grams per mole. Now, this will often be rounded to 16 grams per mole. Okay? Because oxygen is so close to 16 grams per mole that it does not change anything if you round this one. But this is the only one that you should round. Okay? It's the only element that I will accept you rounding. So to find the molar mass of a compound, you're going to multiply the subscript of each element by the molar mass of that element, then add them all together. Okay, you're going to multiply the subscript of each element by mass of then all. Okay, I'm going to do an example. If I have CO2, okay, I look up carbon. We already did that. Okay. And then I know oxygen is 16 grams. Okay. Then I'm going to look at carbon, see it has no subscript, so that's a 1, so times 1. Look at oxygen, it has a 2, so times 2. So of course this one's just going to be 12.011 grams per mole. Actually, we take off the per mole. Hello. I want to erase though. So that's just grams because we've already multiplied by 1 mole. That should be 2. 16 times 2 is 32 grams. Then we're going to add those together. Plus 32 is 44.011 grams. Oopsie. And to fill in the last little bit at the bottom, you're going to have your little bubbles, your arrow, your other arrow, a little bubble here. Okay. This is going to be moles. Mass. To go from moles to mass, you multiply your number of moles times the molar mass. Okay. For a compound, remember you have to do that for each element and then add them together. If we go from mass to moles, you're going to take your mass that you're given, however much it says that you have, and you're going to divide it by the molar mass. And that'll give you the number of moles. So if you have 10 grams of hydrogen, right? You're going to take your 10 grams, divide it by 1.008 grams per mole, and you're going to have like 9 and some change moles. 9.8. Okay. So there are 2 example problems underneath of your little conversion thingy in your notes. What I want you to do is I want you to actually do the 2, okay, on your own. Pause if you need to. Okay, and then I'm actually going to move on to the next set of conversions. So it's going from mass to atoms. Okay, and I'm just going to scroll this down again. And I'm going to flip this over so I know what your guys' stuff looks like, because mine does not always look like yours. Okay, so moles are the universal unit of chemicals. By using moles, you can go from mass to number of atoms. But you have to pass through moles first. So you can go from particles to moles to mass using the conversion factors you've learned in the last 2 videos. And then you're going to be able to go back the other way from mass to moles and back to particles, right? So we know particles to moles is number of particles divided by 6.022 times 10 to the 23 particles per mole. And then from moles to mass, it's number of moles times the molar mass. Right? Now we're going back the other way, going mass to moles. We're going to do mass given divided by molar mass. And then for moles to particles, it's going to be number of moles times Avogadro's number. CLES. There we go. Okay. So this means that we can figure out how many atoms are in a mass sample that we're given. So our example problem is how many atoms in 535 grams of calcium. Okay. Sorry, my nose itched. So the first thing we're going to do is we're going to look up how many, what the molar mass of calcium is. So the molar mass of calcium according to the periodic table is 40.08 grams per mole. Okay. So the first thing I'm going to do is I'm going to combine my conversions to go from mass to moles. So by what I mean by that is I'm going to take my mass given over molar mass and my moles times number of particles, and I'm going to turn it into just one little equation. So we're going to go given mass over molar mass times Avogadro's number. Okay. Because this will give us our number of moles, and then we just have to multiply. So the second thing I'm going to do is plug in the numbers. And this one was combine conversion factors. All right, so I'm going to plug in the numbers. I've got 525 grams divided by 40.08 grams per mole. And then we're going to multiply by that 6.02 times 10, 23 particles per mole. Grams cancel. I'm going to solve. I'm running out of time. So 525 divided by 40 gives me 13.1 moles times the 6.02 times 10 to the 23 gives me 78.85 times 10 to the 23. I'm going to move that decimal over. 7.885 times 10 to the 24th atoms Ca. That's your final answer. All right, go ahead and give it a try on your example problems. guys. I'll see you in the next video.